Hey everyone, welcome back. Sorry, I think there was once again a technical difficulty with the recording. I'm gonna definitely have to get that checked out. Maybe my laptop needs an update or something, because this is definitely happening more than it used to. Um, let's pick up from, I think this is about where we left off. So this was our equation, just to recap really quickly to sort of regather my own thoughts. So yeah, we had our two equations, y equals 2x minus 2 and y equals negative 1/2 x plus 3. Now, we found before that the point of intersection by looking at the graph is at 2, 2. But now we're going to find it using a more mathematical approach. And so basically the thing you have to notice, the key thing you need to notice, is that the y value at the point of intersection, we're talking about the exact same point, right? They have the exact same x value and the exact same y value at this particular point. The key to that is that they have the exact same y value. So these two y values are equivalent, which means I could say 2x minus 2 is equal to y, but y is equal to negative 1/2 x plus 3. So basically I could rewrite it like 2x minus 2 is equal to y, which is also equal to negative 1/2 x plus 3. Get rid of a little piece of the graph there. We don't need that whole thing, right? But the thing is, without even knowing what y is, we know that if 2x minus 2 is equal to this thing in the middle, and this thing in the middle is equal to that stuff over there, then this side, this left side, must be equal to that far right side. So I'm just going to ignore the y, and we're going to say 2x minus 2 is equal to negative 1/2 x plus 3. So basically we've just eliminated that y from the equation. We took the left side, kept it here, we took the right side, kept it over there, and we just forgot about the y in the middle. Now, just because it's getting a little bit late and I really need to get to bed, I'm going to try and wrap this up reasonably quickly. So to save you some of the trouble with going through solving this, when you bring this term over, you'll end up with 2x plus 1/2 x on the left side, and if you take the negative 2 over to that side, you'll switch signs as well, so it'll become 3 plus 2 instead of having a minus 2. So if we go ahead and we do the addition of both of those, we'll end up with 5 over 2 x is equal to 5. I don't know if you can see that quite as well as I hoped. There we go, there at the bottom right there. 5 over 2x is equal to 5. And you can work it out. Hopefully it's not too hard to see, but if it is hard to see, then try dividing both sides by 5 over 2, and you should get that x is equal to 2 when you do that. So that gives us the x-coordinate of the point of intersection, which makes sense because we've got this 2 over here. Now, how do we get the y value for the point of intersection? Well, the thing is, we have the two equations, right? We've got y equals 2x minus 2 up there, and we've got y equals negative 1/2 x plus 3 over here. And so it turns out if you sub in this x equals 2 into either of those equations, it'll spit out the y value, and it should hopefully come out to positive 2, because we know that from looking at the graph that the y value of the point of intersection should be positive 2. So if I erase this, and we just plug in x equals 2, let's plug it into equation 1 first. So we know with equation 1, what we have is y equals 2x minus 2, but we know that the x is actually equal to 2, so that means it's 2 times 2 minus 2. Well, 2 times 2 is 4, 4 minus 2 is 2, and that's it. So that tells us that y is equal to 2 by plugging it into equation 1, which thankfully lines up with the point of intersection that we were seeing earlier. And if we do the same thing with equation 2, hopefully you have this part copied out by now, though I do know I'm going a little bit faster. If we do the same thing with equation 2, we'll end up with y equals negative 1/2 x, x plus 3. And if we plug in x is equal to 2, then we get negative 1/2 times 2 plus 3. Negative 1/2 times 2 is negative 1. Negative 1 plus 3 is equal to 2. And so then we can see that by plugging it into either equation, that spits out a y value of 2 when our x value is equal to 2. So basically when you're finding the point of intersection, you take the two equations of the lines and you get rid of the y part to begin with, and you set the rest of it equal to each other. So you'd say that this negative 1/2 x plus 3 is equal to 2x minus 2. Solve for x, that's what we did here when we got this value for x, and then plug that value for x into whichever equation looks easier for you, and that'll spit out the y value of your point of intersection. Hopefully that makes sense. I apologize for there being a little bit of a cut in this lesson as well, and it being uploaded in 2 parts. I'm going to get that checked out and hopefully record these lessons at a better time, because I'm definitely more prone to making mistakes at this hour, so I'm going to try and work that out. But yeah, hopefully this makes sense. If anything is confusing, let me know and I will re-teach this idea. But yeah, as long as everything is making sense, I imagine I won't hear from you guys until I put the next video out, so I will see you all in the next one. Have a good one.